Welcome to AI Medic Flow, simplifying medical and veterinary statistics. Today we'll break down hypothesis testing using the t-test and ANOVA, also known as the f-test. These are tools used in scientific research to compare group means and test scientific claims. Section 1. What is hypothesis testing? In research, we ask, is there a difference between groups? We set two hypotheses. Null hypothesis H, no difference. Alternative hypothesis H, there is a difference. We use tests like the t-test or ANOVA to decide if the difference is statistically significant. Section 2. The t-test. One sample t-test. This compares a sample mean x to a known population mean μ. Formula: t equals x μ s square root n, where x is the sample mean, μ is the known population mean, s is the sample standard deviation, n is the sample size. If the p-value is less than 0.05, the difference is statistically significant. B. Two sample t-test independent samples. This compares two unrelated groups, like treatment versus control. Formula: t equals xj, x, se. To get SE standard error, SE equals square root SP*1, n plus 1, n. To get SP squared pooled variance, SP equals n minus 1s plus n1s, n plus n2. Assumptions: normal distribution in both groups, equal variances, independent samples. If variances are unequal, use Welch's t-test. C. Paired t-test dependent samples. This compares two measurements from the same subjects, like before and after treatment. Formula: t equals d, sd square root n, where d is the mean of the paired differences, sd is the standard deviation of the differences, n is the number of paired values. Assumptions: paired data. Differences are normally distributed. Section 3. The f-test ANOVA. Use this when comparing three or more group means. Example: comparing 3 dog diets for plaque control. Formula: f equals ms underscore between ms underscore within, where ms underscore between is the mean square between groups. Ms underscore within is the mean square within groups. If p less than 0.05, we reject H, meaning at least one group mean is different. To know which groups differ, run a Tukey's post hoc test. Section for running these tests in SPSS. One sample t-test. Analyze greater than compare means greater than one sample t-test. Two sample t-test. Analyze greater than compare means greater than independent samples t-test. Paired t-test. Analyze greater than compare means greater than paired samples t-test. ANOVA. Analyze greater than compare means greater than one-way ANOVA. Also check the confidence interval CI. If CI does not include 0, the result is statistically significant. Summary table. Test use case key assumptions. One sample t-test compare sample to known value normal distribution. Two sample t-test compare to independent groups normality, equal variance. Paired t-test compare same subjects before and after paired data, normal differences. ANOVA f-test compare 3 or more groups normality, equal variance. Thank you for watching. Subscribe and watch out for our next class.